Okay, so number 37 says, using the formula below, determine the monthly payment on a 5-year car loan with a monthly percentage rate of 0.625% for a car with an original cost of $21,000 and a $1,000 down payment to the nearest cent. So here's this formula. All right, and this number here, P of N, says it's the amount borrowed. PMT is your monthly payment. This should have been an I in here, not a T. I is your interest rate per month, and N is the number of monthly pay periods. All right, so we set this up in class, and then remember we were looking for the first part, it says determine the monthly payment. So we were looking for PMT. So this piece here is the amount borrowed. So if the car is $21,000 and we put $1,000 down, that would mean we're borrowing $20,000. Equals PMT, which is what I'm trying to solve for, times 1 minus 1 plus so 1 plus, so there's a 1 in there, 1 plus the I, which is your rate, and that's going to be 0.00625. I'm going to put the exponent in there in a minute and divide by 0.00625. That's your I. Now, N is your monthly payments, your monthly payment period. So this is 5 years, but you're paying every month. So 5 years is 60 months, and it's negative N. So this is going to be raised to the negative 60. So I just have to move this over. So it's raised to the negative 60, and this is 20,000. Okay, so I told you guys in class to plug this into your calculator and get that number. So, and to use that fraction button. So it's 20,000 equals PMT, and then that number comes out to be 49 points. So make sure you know how to get this. 0.9530818. And then remember we're solving for PMT, so divide both sides by 49.905301818. 49.905301818. So I get my monthly payments are going to be, this is to the nearest cent, it says, nearest cent, $400.76. Okay, so the next part says, the affordability monthly payment is $300. So you only want to pay $300 for the same time period, which means for 60 months. Determine an appropriate down payment to the nearest dollar. Okay, so remember, the car was $21,000 to start off with. So I want to do $21,000, right? That's what we're starting off with, minus some down payment. I don't know what that is going to be. Equals your monthly payment, which is going to be $300, and then I have this here, and I already know what that is. That's that 49.905301818. Okay, remember now I'm solving for X over here. Okay, so I'm going to multiply this together here. So 300 times 49.905 and so on. So that's 21,000 minus the down payment equals 14,971.59245. And then I'm going to subtract 21,000 from both sides. So I get negative X is equal to negative 6,028.40755. And then that would mean that positive X is equal to $6,028. And that was the nearest dollar. So that's how much you would have to put down on the car to have a monthly payment of $300. Okay, so let's try the next problem. Okay, so 37 says the speed of a tidal wave S, so S is the speed, in hundreds of miles per hour can be modeled by the equation S equals the square root of t minus 2t plus 6, where t represents the time from its origin in hours. So t is hours, S is the speed of the tidal wave in hundreds of miles per hour. Algebraically determine the time, so I'm solving for t, when S equals 0. All right, so I'm going to replace S with 0. 0 equals the square root of t minus 2t plus 6. So it's now becomes a radical equation, so I have to move this stuff over to the left. So I add 2t and minus 6. And to solve a radical equation, we square both sides. So I square the radical, and I square this side here. So when I square the square root, it just becomes t equals, and now I have to do 2t minus 6 times 2t minus 6 equals t. And now I'm going to solve that. All right, so I double distribute, I get 4t squared minus 12t minus 12t plus 36 equals t. So I get 4t squared minus 24t plus 36. It is a quadratic, equals t. It is a quadratic, has to equal 0, so I minus t from both sides. So I get 4t squared minus 25t plus 36 equals 0. All right, now I have to solve this. All right, so you can use the quadratic formula. You can complete the square. I wouldn't complete the square, actually, because I would have to divide everything by 4, and you're going to get fractions in the middle. So you can complete the square. You could try to factor. So I'm going to use the quadratic formula because I don't want to sit there and try to factor this. So quadratic formula is x equals, in this. So actually it's t equals. So it's t equals negative b plus minus the square root of b squared minus 4ac all over 2a. So I get t equals 25 plus minus the square root of negative 25 squared minus 4 times a, which is 4, times c, which is 36, all over 2 times a, which is 4. Okay, so now I get t equals 25, and underneath the radical, I get the square root of 4, so I get 49, square root of 49 over e. So then this becomes, the square root of 49 is 7, so it's 25 plus minus 7 over 8. So I get t equals 25 plus 7 divided by 8 is 4, because it's 32 over 8, which is 4. And t equals 25 minus 7 divided by 4 is 9/4, and this does not work. Okay, so you have to make sure you cross off. So when I'm saying it doesn't work, you have to always plug it into the original and see if it works, because it's a radical equation. So always check to make sure it works. Okay, so that doesn't work. So it will take, so what this means is it will take 4 hours for the tidal wave to stop moving, basically. It becomes 0 miles per hour. Okay, so the next part says, how much faster was the tidal wave traveling after 1 hour, so t equals 1, and then after 3 hours? All right, so I want to know how much faster. So I have to figure out how fast the tidal wave was traveling at 1 hour. All right, so I'm going to plug it in. So I'm looking for the speed of the tidal wave. F equals, and that is the square root of 1 minus 2 times 1 plus 6. and this comes out to be, the speed is 5. So remember, the speed is in miles per hour. That does not mean the tidal wave is moving 5 miles per hour. Remember, it's in hundreds of miles per hour, so you have to multiply that by 100. So at 1 minute, the tidal wave is moving at 500 miles per hour. All right, when t equals 3. So s equals the square root of 3 minus 2 times 3 plus 6. So this comes out to be 1.732050808 multiplied by 100. So this comes out to be 173.732. So I want to know, so obviously after 1 hour, it's traveling much faster than after 3 hours. So now how do I figure out how much faster? I subtract them. So it's 500 minus 173.732. And it is to the nearest, so I get 326.79. And it's to the nearest mile per hour, so it's 326 miles per hour it's traveling. How much faster it's traveling at 1 hour. Okay, so that's it. You need to study for your test tomorrow, and what I would like you to do for tomorrow is bring in a pencil for tomorrow. Okay, so please make sure that you do have a pencil. All right, and I'll see you tomorrow. Okay, happy studying. Good night.